We're in Chapter 8, Section 1. In this section, we will be reducing rational expressions. Our objectives are to determine what values of the variable, if any, will make a rational expression undefined, find the numerical value of a rational expression, and we're going to reduce rational expressions to the lowest terms. So what is a rational expression? Well, it is an algebraic expression that can be written in the form P over Q, where P and Q are polynomials and Q is not equal to 0. So remember at the beginning of the semester, we talked about numbers. If you have a number that's undefined, that's when you have any kind of number divided by 0. If you type 5 divided by 0 in your calculator will tell you made an error because dividing by 0, you just can't do that. So it's considered undefined. So, introduction to rational expressions. To determine which variables make a rational expression undefined, you're going to set the denominator equal to 0. You're going to solve the resulting equation. The solutions to this equation are the values that make the expression undefined. And these values are going to be called restrictions. So, for example, if we have a fraction or a ratio of two rational expressions, it's a valid value unless the denominator is equal to 0. So it's asking us, what are the restrictions on this variable? What could that variable not be? Well, in order to figure out the only value that variable could not be is by setting the denominator equal to 0. Now, can you have 0 divided by a number? If you type that in your calculator will tell you the answer is a real number. It's 0. So it doesn't matter if the numerator is equal to 0. It only matters if the denominator equals 0. And if it does, the value is undefined. So that's why we're taking the denominator only. We're setting it equal to 0 to find out the restrictions of the value of x. So to solve for x, you're going to add 1 to both sides. So then we'd have 2x equals 1. And then to get x by itself, you're going to find that x is equal to 1/2. In other words, if x is equal to 1/2, well, 2 times 1/2 is 1, and 1 minus 1 equals 0. So when x is equal to 1/2, that means that this whole rational expression is undefined. So when it says that x is equal to 1/2, that literally means that x cannot equal 1/2. It could equal 2, it could equal 10, it could equal negative 100. The only thing that x cannot be is 1/2, and that's why these are called restrictions. So x cannot equal 1/2. All right, let's look at letter B. It doesn't matter if the top equals 0, the numerator, but you cannot have a valid expression if the denominator equals 0. So that's why you take what's in the denominator and you set it equal to 0. Well, that's a quadratic equation, and that's what we did last chapter. So you're going to unfoil that. You're going to look for two numbers that give you a product of -3, but a sum of -2. This sign means the two numbers are different signs, and this means the bigger of the two numbers is negative. So the only factors of 3 are 3 and 1. So does -3 times +1 equals -3? Yes. Does -3 plus 1 equal -2? Yes, that's exactly right. Now remember, to solve quadratic equations in our last unit, we had to set both of these equal to 0. And we're doing this to figure out what our restrictions are. So if we're going to add 3, m can't equals 3, which literally means it couldn't equal 3. So there's two answers on this one. So if m was 3 or -1, this rational expression would be invalid. It would be undefined. So when it asks for restrictions, the answer on this one is m cannot equal -1 or 3, or in other words, the restrictions are 3 and -1. Those are the two values that would make that variable expression undefined. All right, so determine which values make a rational expression undefined. Here we have a note: if the denominator is a constant or the denominator is not factorable, then there are no restrictions on the variable. For example, if it's the first one, if it's a constant, that means just like a whole number. Like if I had 5/4, well, the denominator is not 0, and it will never be 0 because I don't have a variable. So there's nothing I can never make a 4 0 because it's not being multiplied by a variable. And so if the denominator is a constant, that means there is not a restriction for this number. Even if there's a variable in the numerator, there would be no restrictions on this. Now, if you look at this one, these two numbers are perfect squares. If this were a minus right here, we could break this down by finding the difference of two squares. But remember, if you have the two squares and there's a sum, there is no way that you can factor this to get a middle term of 0. Okay, so since this denominator is not factorable, then if it asks for restrictions on a problem like this where the denominator is not factorable, then you would just say there are no restrictions. There's no restrictions if the denominator is not factorable, and there's no restrictions when the denominator is a constant, if you don't have a variable in the denominator. All right, so let's go on to example 2. All right, it says find the value of each rational expression for the given value of the variable. Now this one is simply asking us to substitute x2 for x, and we've done this through each unit. So on the top, so in other words, this isn't asking what the restrictions are. All it wants us to do is substitute on this particular problem. So if x is 2, so we're going to multiply 2 times 2 over x is 2, 2 squared plus 1. Well, 2 times 2 is 4. 2 squared is 4, and 4 plus 1 is 5. So we have evaluated this rational expression. So letter B wants us to figure out what is the value of this expression if a is equal to 3. So on the top, we're going to put 3 equals 3 over 3 squared minus 5. So 3 minus 3 is 0. 3 squared is 9, and 9 minus 5 is 4. So what is 0 divided by 4? The answer is 0. You guys know how to do those already. All right, so here we're moving on. It says we're going to reduce each rational expression to lowest terms. We're going to state any restrictions on the variable. Remember, no denominator can be 0. That's why we have to find the restriction to make sure we never get a denominator of 0. This restriction applies to denominators before and after a rational expression is reduced. So the first thing we're going to do is figure out what the restrictions are. And so you want to know what the restrictions are before you simplify everything. So the first thing I'm going to do in letter A is I'm going to take my denominator. I'm going to set it equal to 0. I'm going to subtract 6. I have 3x equals -6. And when I divide by 3, I know my restriction is x cannot equal -2. Okay? So I know that if I end up with x equals -2, then I know my rational expression is undefined. All right, but now I know what the restriction is. And in Hogs, you have to do both of these. You have to simplify it and you have to find the restriction. And on your test for Chapter 8, you'll have to do that as well. So find the restriction first. Then let's go ahead and simplify the numerator and the denominator. And then finally the entire ratio. So look at these two terms. What can we divide 2x and 4 by? Well, we can divide them both by 2. So 2x divided by 2 is x. And 4 divided by 2 is positive 2. So that's our numerator. On the denominator, what can we divide 3x and 6 by? We can divide both of them by 3. So 3x divided by 3 is x. Positive 6 divided by 3 is positive 2. All right, so now, is there anything that will cancel out on the top and bottom? Yes, x plus 2, x plus 2. Now, when there's a plus sign between two variables, that plus sign holds together that whole expression. Because let's pretend for a second the top said x plus 2 and the denominator said x minus 2. Well, some people will go, oh, well, the x's will cancel. Actually, they would not, because that plus sign holds all of this together and that minus sign holds all of this together. So this expression is not factorable because these don't match exactly. However, when we got up here, we got x plus 2 on top and bottom. Since those match exactly, this expression cancels out this expression. And so we've simplified this whole expression right here to 2/3. Now let's check our restriction. Can we have an answer of 2/3? Yes, we can. The only thing we cannot have for our final answer is -2. So since this is not equal to -2, we've just simplified this rational expression. We've reduced it. Okay? So all of that was letter A. Oh my goodness, where you're going to be running out of room. All right, now let's look at letter B. So letter B, first thing I'm going to do is figure out my restriction. So I take the denominator, I let it equal 0. I'm going to add those to both sides. I'm going to add 4. So we figured out our restriction is 4. That's our restriction. And really, I could almost put it not equal to. X cannot equal 4, because that's if x was 4, isn't 4 minus 4 0? And that would make all of this invalid, or undefined, I should say. All right, so that's our restriction first. And in HOX, I think it even tells you, it gives you a little box and it says x is not equal to. It gives you that little slash symbol, and all you do is type in what the restriction is. All right, so moving on. Now we're going to reduce it. Well, this on the numerator, this is the difference of two perfect squares. So we're going to unfoil it. We're going to say, what is the square root of x squared? The answer is x. What's the square root of 16? 4. And if it's the difference of two squares, one gets a plus and one gets a minus. Now, if you FOIL this, you're going to get what we started with. All right, so that's the numerator over the denominator. Now, remember that minus sign holds this whole expression together. So can we cancel something that's exactly the same on top and bottom? Yep, we sure can. That goes away. It's just 1, and 1 times x plus 4. The answer is x plus 4. That is that expression right there simplified. These have the same value. All right, so that's letter B. Letter C. Letter C, first thing we're going to do is find our restrictions. So we're going to set the denominator equal to 0. Can I pull something out of both of these? Actually, let me, All right, so can I simplify this? Let's see. Well, if I pull A out, well, I have to set it equal to 0. So what I'm going to do is I'm going to add 5A to both sides. I don't think that's going to work. Let me see if I can pull out an A. I'm trying to reduce this. So my constant would be 0, wouldn't it? All right, so is there a number? Two numbers, when I multiply, I get 0. And when I add them, I get 5, -5. Well, that would be -5 and 0. Yep. Yep, that's what it would have to be, because if I FOIL this, a times a is a squared, a times 0 is 0, 0, then in the middle I'd have negative 5 times a, which would be negative 5a, and then negative 5 times 0 is 0, so that's what I would get. Okay, so the only thing 5 could not be, oh, and here if I just took what was in the parentheses and set it equal to 5 or 0, I would have gotten that a cannot be 5. Whoops, a cannot be 5. Yep. If you just take what's in the parentheses and set it equal to 0, you'd get the same thing. Sorry, I made that much more complicated than it had to be. All right, so my restriction is 5. A cannot equal 5. That's my restriction. All right, so now I'm going to go back to my original equation. A is on the top. On the bottom, I've already figured out I can divide both of these terms by a, and I get a, well, a squared divided by a is a. Negative 5a divided by a is negative 5. Now, remember I told you if there's a plus or minus, it holds that expression together. But I can divide a divided by a. And what do I get? 1. So this expression simplified is 1, because you can't have nothing on the top, over a minus 5. And that is my answer simplified. I've reduced the equation, or the expression, I should say. All right, so then letter D, and this was one of my Hawks practice problems. So the first thing you want to do is find your restrictions. So these two numbers are perfect squares. So you're going to divide up the x squared. Square root of x squared is x. 225 I think is 15, but just to be double sure, I'm going to put it in my calculator. Yep, so the square root of 225 is 15. So since it's the difference of two squares, one gets a plus and one gets a minus. So now I have two parentheses. I'm going to set them both equal to 0. And then if I subtract 15, I would find that the restrictions are negative 15, and if I add 15 to 0, I get positive 15. So x is not allowed to be 15 or negative 15. All right, so now I have to see if I can reduce this. So I'm going to put x over x plus 3 over, well, I've already broken this down, haven't I? X plus 15, x minus 15. And does anything cancel? No, it does not. So this original fraction or ratio cannot be simplified. So if it asks what is this expression simplified, you can put it in its original form, or you can put it in this form where we broke down the denominator. And technically those are both correct. This didn't help us cancel anything, so this step isn't 100% necessary, but just to make sure nothing cancels, it is always smart to break those down. So anyway, Hawks would accept either this answer or that answer. All right. All right, so just a reminder, when you have fractions and negative signs, it doesn't matter where that negative sign goes. You can put it in front of the fraction. You can put it in the the numerator, or assign it to the denominator. You just can't put it both. Okay. For polynomials P and Q cannot equal 0. Why can Q not equal 0 and B can't equal 0? Because that means that expression would be invalid or undefined. So if it's a negative fraction, you can leave it in the front. You can give that negative sign to the numerator or the denominator. Either way. All right, so that's going to help us. That information is going to help us with A and B, because look what we have here. In front of both of these, we have a negative sign. So you have to decide, where am I going to put that negative sign? Well, just be consistent. I almost always will assign it to the numerator. And you can do it to the denominator, but I just always do it to the numerator. So I'm going to say, okay, so what is the opposite of negative 2x plus 6? Well, the opposite of negative 2x is positive 2x. The opposite of plus 6 is minus 6. Okay? Now, since I'm trying to reduce, I'm going to look at the numerator and decide what can I divide both of those numbers by. Why did my screen just go so... What in the world just happened? Okay. Let's pretend that didn't happen. All right, so anyway, sorry about that. So now in the numerator, what can I divide both of those terms by? Well, the answer is 2. So 2x divided by 2 is x, and negative 6 divided by 2 is negative 3. All right, and the denominator, what can I divide x squared and 3x by? Well, the answer is x. What's x squared divided by x? X. What's negative 3x divided by x? Well, I'm taking out the x, and I have that left. So can I cancel anything out in the numerator and denominator? Yep, I sure can. Those go away. So my answer is x over 2. That is this expression simplified. All right, letter B. I'm going to see what can I divide out the top. Oh, first I have to assign that negative number. So I'm going to write the opposite of 5 minus 10x. Well, the opposite of 5 is negative 5. The opposite of negative 10x is plus 10x. And I'm going to put that over my denominator. Now, what can I divide negative 5 and 10 by? I can divide them, you can either think I can divide them both by 5, or I always try to make that first number a positive. So I'm going to pull out a negative 5. So negative 5 divided by negative 5 is positive 1. 10x divided by negative 5 is negative 2x. All right, and the denominator, what can I divide out of both of these? 6 and negative 3. Well, I'm going to go ahead and pull out a negative 3. Negative 3. So 6x divided by negative 3 is negative 2x. And negative 3 divided by negative 3 is positive 1. Now look what's happened here. Can't I rewrite this negative 2x plus 1? Let's do that. Negative 2x plus 1. I can rearrange the numbers as long as I keep their sign with them. And when we rearrange it on the bottom, don't we already have negative 2x plus 1? We sure do. So those cancel. And then the last thing we have to do is think, okay, what is a negative divided by a negative? And of course the answer is positive 5/3. So in Hawks, if you try to put negative 5 over negative 3, it'll tell you your answer is not simplified. So you'll have to finish that and make them a positive number. All right, so I've given you 4 problems to do, and I think I've given you the answers to them. So hopefully you guys will stop the video and you will try those. And then come right back, check your answers, come right back and see if you need me to explain them to you. All right, so I am going to, it says have first reduce, then find restrictions, but I always like to find the restrictions first because you want to use the original problem. You're not going to use the answer after you've reduced it. You have to always reduce the original expression. All right, so number 1, I have 2 perfect squares, and I see a plus between them. Well, if it was a negative between them, I know it would be x plus 2, x minus 2, but you cannot simplify, you cannot reduce the sum of 2 squares. So since the bottom is not factorable, there are no restrictions. No restrictions. Well, restriction, oh my gosh, I just suddenly forgot how to write or spell. And since there's no restrictions, I could break this down to x times x, and I could do this x times x, but it's connected to that plus 4. I have to bound all of this together because of that plus. So there would be nothing I can simplify. Okay, so there's no restrictions, but there's also no way to reduce that either. All right, number 2. So the first thing I want to do is try to reduce, or excuse me, see what the restrictions are. So I take my denominator, 7x squared minus 7. I'm going to set that equal to 0. Well, what can I divide both of these by? I can divide them both by 7. So then 7x squared divided by 7 is x squared. Negative 7 divided by 7 is negative 1. Well, this is the difference of two squares, right? Isn't 1 a perfect square and x squared is a perfect square? So the square root of x squared is x. Square root of 1 is 1. And then since this is a minus, 1 gets a plus and 1 gets a minus sign. So then I take both of those parentheses and I set them both equal to 0. So x plus 1 equals 0 and x minus 1 equals 0. Here I'm going to subtract 1, so I know that x cannot equal negative 1, and here I would add 1, nor could x equal 1. So those are the restrictions. Now, if you notice, I just kind of ignored the 7. And the reason I did that is because this has no variable attached to it, so I can never make this value 0. Now, if it had a variable attached to it, then I do have to set it equal to 0. I would divide both sides by 7, and another restriction would be 0 divided by 7 is 0. But if it's just a constant, you can't ever make that value a 0 because it has no variable. So when you get down to this part, basically you can just ignore that constant, okay? All right, so on number 2, all we've done so far is we've figured out what the restrictions are, but we still have to simplify it. So on the top, so the top and bottom, both of them can be, everything can be divided by 7. So this is x minus 1 on the numerator. The denominator, we already figured out what that is. We have x plus 1, x minus 1. Now, everything that cancels. Oops, sorry about that. All right, can I divide 7 by 7? Yes, I can. 7 divided by 7 is 1. Can I divide x minus 1 divided by x minus 1? I sure can. And so what do I have left in the numerator? Well, the numerator I have 1. 1 times 1 is 1. And then the numerator I have x plus 1. I don't need those parentheses, but I just wrote them because it's a habit, I guess. So my restrictions are 1 and negative 1. And this simplified is this expression right here. All right, number 3. First thing I'm going to do is figure out what my restrictions are. Well, I have the difference of two squares. So I'm going to find the square root of x squared is x. Square root of 4 is 2. Since it's the difference of two squares, one gets a plus and one gets a minus. Whoops. Pretend that's a minus. So now I'd set this equal to 0. X minus 2 equals 0. When I subtract 2, I'm going to get 0 minus 2 is negative 2. And when I add 2, I would find out that x cannot equal negative 2 or 2. All right, so now I'm going to reduce the whole expression. So I go to the top and I think, what can I divide negative 4 and 8 by? Well, the answer is negative 4. Well, negative 4x divided by negative 4 is positive x. Positive 8 divided by negative 4 is negative 2. And then in the numerator, I've already broken it down to x plus 2, x minus 2. And what do I see that cancels? These cancel, they match perfectly. And the final answer is negative 4 over x plus 2. Negative 4 over x plus 2. All right, I'm about out of room. So number 4, first thing I'm going to do is find the restrictions. So I'm thinking of two numbers. When I multiply them, I get negative 10. But when I add them, I get negative 9. Well, that would be 10 and 1. So my bigger of the two numbers is negative. Negative 10, positive 1. I'm going to set them both equal to 0. If I add 10, I'd find out that A cannot equal positive 10. Or if I subtract 1, negative 1. Those are my two restrictions. Now I'm still reducing number 4. So on the top, the numerator, I'm thinking of two numbers. When I multiply, I get negative 9, but when I add, I get negative 8. Well, that would be 9, negative 9, and positive 1. Because that's negative 9, and then negative 9 plus 1 is negative 8. On the denominator, I already know that that's A minus 10, and then A plus 1. And then what do I have that matches? Those two. And so my final answer is A minus 9, A minus 10, over A minus 10.